Okay, so what we're doing today, this lesson is about section 9.3, similar right triangles. And so before we get into what similar right triangles look like, we need to actually talk about a geometric mean. You have an arithmetic mean, which is just the regular mean, where if I have two numbers, I would add the numbers up and then divide by how many numbers there are. The geometric mean, to find the geometric mean of two numbers, what you do is you multiply them and then you take the square root. If it was three numbers, it'd be the third root, but it's just two numbers, so it's square root. So it's the square root of 8 times 18, which is the square root of 8 times 18. Oh, calculator died. 8 times 18 is just 144. And we need to break this down, and the square root of 144 is 12. So the geometric mean of 8 and 18 is 12. Now if I do the geometric mean of 7 and 21, I would multiply them. And so 7 times 21 is 147. That's super small. Hold on. So the square root of 147. 147 is something you would need to break down just to make sure. 147 is 7 times 21, which we knew there, and that's 7 times 3. In order to take a radical, you have to have two of them, so I can have a 7 on the outside, and then this is left over, so the answer for this one is 7 square root of 3. If you are not required to find those, then you could just find the square root of 147. And you can write the decimal of 12.12. Both answers are correct. It kind of depends on what your teacher or your assignment is asking you to find. All right, so that's how you find the geometric mean of numbers. Now what we're going to do is we're going to look and see what happens with right triangles. So what happens is I have three triangles. I have the big one that's on the outside. I'll try and trace that yellow. Right? And then if you notice, I also have two small ones. I have this small one here, this one that we'll call the green one. And then I have kind of a medium-sized one, which will be blue. Okay, so what we need to do, first of all, to kind of understand what's going on, is we're going to redraw this. I'm going to redraw my large one. And I really want to emphasize the longer leg. And then here's my medium one, the longer leg's here. And then here's my small one, still longer leg. They don't have to be drawn to scale, but you really want to make sure that you could tell where your short leg is and your long leg. So for my big triangle, it's just going to be A, B, C. Now my medium triangle, the right angle is always the easiest place to start, and my right angle on my medium triangle is right here, D. Now, you see I need to go up to my short side. So from D, my short side takes me to B. And then that means that my long leg goes to C. And then now I need to look at, and maybe we'll color that in so we know that's the blue one. And then now I need to look at my small triangle. And so my small triangle, again, start with the right angle. That's the easiest place. And the right angle over here is D. And then now I'm going to my short leg, which goes up to A, and then that tells me that my other leg is B. So one of the things that you may want to do, and this is a strategy that will help you visualize things easier, is draw the three pictures. But you might also do okay just recognizing, okay, where's my short leg, where's my long leg, and we go from there. Now what this right triangle happens, with these right triangles, what happens is that it creates three similar triangles. So triangle ABC is similar to triangle BDC, which is also similar to triangle ADB. And so because we have so many similar triangles, we're going to be able to write several different types of proportions and solve them to find missing sides. Okay, so here's a problem that we need to do. We need to find all those sides. So we're going to say AB is X, BD is Y, and BC is Z. So I would start off by drawing your three triangles. There's the big one, there's the medium one, and there's the small one, And again, you want to make your long leg definitely longer than the others. Now, I'm not going to label like we did up above. I'm just going to try and see if we can fill in our information. Okay, so let's highlight, though, because that will be helpful. Here is our big triangle. And on our big triangle, our long leg is X. Our short leg is Z. And then our hypotenuse is this whole thing, which happens to be 10. Okay, so now let's go to our next one. Our medium triangle. And on our medium triangle, our hypotenuse on this blue one is X. Our short leg is right here, Y. And our long leg is 7. And then lastly, let's go to our small triangle. And on our small triangle, our hypotenuse is Z. Our short leg is 3. And our long leg is Y. Okay, now what we need to do is you have to kind of, you got to figure out what you're going to solve for, and this can kind of be tricky. But you just can't solve equations that have two variables at the same time. You can have one variable at the same time, but not two variables. The one that stands out to me now is I could do 10 over X, and then I can do X over 7. Okay, so then when I do this, you cross multiply. This is the only time I like to talk about something as cross multiplying, but I get X times X, which is X squared, and then 10 times 7 is 70. And then to get rid of a square, you square root it, so X is the square root of 70, which is just 7 times 10, so you can't break it down, so that's the answer. Okay, so now I'm going to erase those circles, hopefully. Let's see if I can do that. Erase part of the circle. And then now we have to do the same kind of process with Y and with Z. So see if you can find out where you have just Y's or just a Z to try and solve a problem. Okay, so let's do a different color. So here's Y. I have Y is in the same place as 3. And then I have 7 is in the same place as Y. So Y over 7 is the same as 3 over 7. You also could have done Y over 3 is the same as 7 over Y. Oh, what did I do? This is supposed to be a Y. Okay. And so now again, cross multiply, only time I talk about that. Y times Y is Y squared, and 7 times 3 is 21. And so I take the square root of that, and I get the square root of 21, because you can't break down 21. All right, and now I'd like you to do the same idea with Z. And when you think you have it, press play. Okay, so here's my Z, and then here's my other Z. So this Z is in the same place as 3, and this Z is in the same place as 10. So that's what I'm going to do. I'm going to use those. And so I'm going to have Z over 3 is the same as 10 over Z. What you should recognize, though, is that each time you set this up, all three of these, the variables were across from each other. So they have to be across from each other or diagonal from each other. Okay, and so now when I solve this, I get Z squared is equal to 30. And so Z is the square root of 30, which you can't break down. Okay, you can find out what they are as decimals, but you can also keep them as radicals. So this is a little difficult, but if you draw your triangles, you will be able to find them. So if you notice, my thing that I'm looking for is in the center, and it has nothing to do with the big one. So I'm just going to do my medium and my small. My small triangle, the short leg was 2 and the long leg was X. for my medium triangle, the short leg is x and the long leg is 6. And so now you can see how I'm going to set this up. X is in the same place as 2, and then 6 is in the same place as x. And so I'll cross multiply and get x squared is 12. And so x is the square root of 12. Square root of 12 can be broken down to the square root of 4 times 3, because 4 times 3 is 12. And so the square root of 4 is 2. So it's 2 square root 3. If your teacher is okay with leaving it like this, you can do this also, or you can plug it in and find the decimal. Okay, so let's look at the next one. EH. And if you notice, I don't really have any numbers on the small triangle. So the two triangles I want you to draw, I'd like you to draw the large triangle, the big one, and I'd like you to draw the medium triangle and label them. And once you think you have them, go ahead and press play. So if you're looking for EH, or I'm sorry, EF, which is X, on the big triangle it's the long leg, on the medium triangle it's the hypotenuse. And so now we'll set it up. 16 over x is equal to x over 12. And so I get x squared is equal to 16 times 12, which is 192. If I break this down, I know that it's the square root of 192, but I know it's 16 times 12, and 12 is 4 times 3. So what I can do is I can take this out, which is a 4, because the square root of 16 is 4. Then I can take this out, which is 2, and then this thing's stuck underneath. So the answer is 8 square root 3. And again, your teacher may accept square root of 192. They may want 8 square root of 3, or they may even accept the decimals. Okay? But again, what I did was I looked to see what triangles have those two shapes, and then I went from there. All right, the last two are harder because they have two sides you have to find. So let's go ahead and start with number 5. And if you notice, the triangles I'm dealing with are my small and my medium. So I'm going to draw my medium and then my small. Okay, so press pause and try and see if you can find those measurements and label them, and then press play when you're ready. Okay, so what I'm going to work with is the x's. So I'm going to have x over 8 and 3 over x, which is x squared is equal to 24. 24 is the same as 4 times 6. So the square root of 4 is 2. So x is 2 square root 6, because I can't take anything with 6. Okay, and then now I'm going to try and find y. Now if you notice, y is on this small triangle. So what I can do is I can just say this is 2 square root 6, and now I can use Pythagorean theorem. 3 squared plus 2 square root of 6 squared equals y squared. So that's 9 plus 24 is equal to y squared. So y squared is 33. So y is the square root of 33. And the reason I know that 24, this gave me 24, is because to get rid of a square root, you square it. So I'm just squaring this thing, and so it's going to get me back to 24. All right, why don't you try number 6, kind of do the same process, and then press play when you think you have it. Okay, so you should have been able to set this up, and if you notice, I'm going to solve for x first. And so it's x over 2 square root of 3. Come back and do 2 square root of 3 over 2. And so now I'm going to times by 2 square root of 3. Which is going to look funny, but here, let's do it this way. This 2 is going to cross off with this 2. And so I have a 2 on the outside. And then the square root of 3 times square root of 3 is square root of 9, which is 3. Ooh, look at that 3. So I get 2 times 3, which is 6. Now, similar to what I did over there, if you notice, I already have Pythagorean theorem. So I'm going to do 2 square root of 3 squared plus 6 squared equals y squared. And I'm going to solve from there. And there it is, solved.